Okay, we're continuing our discussion of graphing trig functions, and we're graphing secant and cosecant. You've already graphed a secant curve, and the key to graphing the secant curve is to graph the corresponding cosine curve, and then wherever the graph crosses the x-axis, the cosine graph. That's where you'll have the vertical asymptotes, and then you draw what I refer to as the reciprocal curves, these little U-shaped figures. I printed out the homework before class, and the downside to my getting paper prints, the copies of this, is you can't click the little magnifying glass and blow it up. So I can zoom it like this. This is problem number 1. Graph y equals 3 cosecant x. If you were going to guess, and your life depended on it, which two would you not guess? A and B. So you have a 50-50 shot at guessing and living. You were just going to guess, and suppose your life depended on it, and you had to guess. You wouldn't guess A or B. And this is number 2 here. Underneath it, if your life depended on it, which ones would you not guess? B and C. These look like sine or cosine and tangent or cotangent here. And the same thing down here. A secant and cosecant should have the little U-shaped curves. So we're going to graph y equals 3 cosecant x. This is problem number 1 in our homework. Graph y equals 3 cosecant x. Well, what am I going to graph first?
3 sine x.
So let's graph y equals 3 sine x. Cosecant doesn't have an amplitude that's defined, but sine sure does. Here the amplitude would be 3. So it's just going between 0 and 2 pi. There's no need to take the angle and set it between 0 and 2 pi like this one up here, because the angle is just x. So if you did that, x is between 0 and 2 pi. Okay. Let's see. Let's see. Maybe I'll make it small. Okay. 0 to 2 pi. Each one of these is going to be pi over 2, pi, 3 pi over 2, 2 pi. And it's bouncing between, drat. Should have left more room. You know what I'm going to do? I'm going to do this the real lazy man's way. On the y-axis, each little mark is going to just be 3. Because I should have had this lowered some. So I'm using each little mark as 3. And this is sine. Sine, is it the one that starts on the x-axis, or does it start up at 3? It starts at it goes 1, 2, 3, 4, 5. So here's the red graph is not going to be the graph of my answer. My answer, let's see, there's a vertical asymptote here on the y-axis. I'm trying to dot that. It might not look it. And then right here at pi. And then you draw the little reciprocal curves. Ooh-wee. Like that. And like that. And let me see. Here are the answer choices. I'll fold it like this so we can see. Let's see. Okay, I think we can say it's not A or B. Let's see. Notice, again, if you had it, if we were doing these live, if they weren't printed out and you could click the little magnifying glass, that'll look a lot better. how to decide between C or D. Which one of these looks like there should be a vertical asymptote on the y-axis? It shouldn't be crossing that y-axis. With that in mind, which one is it?
D.
It's D. Okay. The U-shaped figures are the answer. Theoretically, they should show the asymptotes, but sometimes in these little small graphs, it just gets too difficult to read if it's showing the asymptotes also. But not all of them. Looks like number 2 is going to have some asymptotes showing. And what is problem number 2? Well, number 2. -4 secant 1/2 x. That's what we're going to graph. You can already guess it's not going to be B or C. Okay. So, we're going to start off graphing y equals -4 what? Cosine? So it's number 2. So the key to be able to graph the secant and cosecant is to be able to graph sine and cosine. Okay? So let's see. Number 2. I am graphing y equals -4 secant 1/2 x. What do I have to graph first? I think you've already said it. Cosine. Let's see, maybe use a different color. How about this one? I'm going to graph y equals -4 cosine 1/2 x. Oh yeah, that pink shows good. What's the amplitude for -4 cosine 1/2 x? 4. The angle is 1/2 x, so I'm going to set that between 0 and 2 pi. So what x value will give us angles from 0 to 2 pi? What would I need to do to solve this for x? Maybe multiply by 2. So is it going to wind up being 0 to 4 pi? So we'll get one cycle on the x-axis, 0 to 4 pi. Let's see. Okay, so 0 to 4 pi. I guess if I wanted to just make it too small, I could just say, okay, each one of these is pi. 1, 2, 3, 4. What if I do each little box being pi over 2? 1, 2, 3, 4, 5, 6, 7, 8. So there's 4 pi. Right here, 3 pi. 2 pi, pi. And what's it bouncing between on the y-axis? 4, -4. 1, 2, 3. 4. 1, 2, 3. -4. So we're graphing cosine. A cosine x, when A is positive, it normally starts up here at +4. But because this thing, first number being negative, remember how it starts? It starts at -4. Y'all caught up with me? So 1, 2, 3, 4, 5. Sometimes students say, well, heck, I can draw it without drawing the curve. Could y'all, based on that, could y'all tell where the asymptotes are going to be? If we didn't connect these, it's going to be right here, just at pi and at 3 pi. Again, if you want to draw it, okay. And the little U-shaped curves, you start here, draw it like that, like that. Oh, maybe, let me see, how does this, okay, there it is unzoomed, and move this up. Ooh, maybe a better. Okay, so which one does it look like? Why don't we target, say, the y-axis? Look at what the graph should be doing at the y-axis. Should be down here at -4 going down. So we've already said it's not B or C. So which one on the y-axis, like A? It's not A, is it? Because it's not down at -4. I'm thinking it has to be D at -4. And on the y-axis, see, now, I just drew that primary interval. What x values give us, make the angle go from 0 to 2 pi? Well, these things keep going and going and going, and so maybe they didn't draw that same primary interval, and they didn't, did they? Looks like they drew from -pi to 3 pi. Okay, but you agree, if we continue, it's going to go like this. And so, can I coerce y'all into agreeing it's got to be D? Any questions? Let's find a really messy one now. How about, oh, number 3. I'm going to do number 3 now. Oops, no, that's not it. Number 3, y equals -1/4 cosecant x plus pi over 2. Which 2 would you not guess if you were guessing?
What, A and D?
Yeah, you wouldn't guess A or D. Those look like sine and cosine curves, don't they? So, graphing, y equals -1/4 cosecant x plus pi over 2. Okay, let me write it down. So this is number 3. Y equals -1/4 cosecant x plus pi over 2. Now the first thing we're going to have to graph, and it showed up so well earlier, I thought. So we're going to graph y equals -1/4 sine or cosine? Sine x plus pi over 2. And the amplitude for sine is defined. What two numbers are they going to be, the sine curve going to be bouncing between?
0 and 2.
Oh, you're getting ahead of me. The angle be between 0 and 2 pi. And the amplitude, just 1/4. So the number on the y-axis that sine is going to be bouncing between will be +1/4 and -1/4. Now the amplitude for cosecant isn't defined. So when I talk about amplitude, it's the sine curve here. So let's see, how do I want to go about solving this thing for x? Would it just be maybe subtract pi over 2 all the way through? So we would have -pi over 2, and x in the middle. Now thinking of that 2 pi is 4 pi over 2 minus 1 pi over 2. Is that going to be a 3 pi over 2? And draw the graph. Let's see see. I think I'll use green. It's going to go from negative pi over 2 to 3 pi over 2. I could either let each little box be, how about I do that? I'm going to let 2 of the little boxes be pi over 2. So to get to 6 pi over 2, pi over 2, 2 pi over 2, to get to 3 pi over 2, I mean. So right here would be pi over 2 and there pi. And on the y-axis, what numbers am I going to label? Will it be 1/4 and negative 1/4? So just one little box on the y-axis for negative pi over 4 and pi. Excuse me, for negative 1/4 and positive 1/4. And sine, does that start on the y-axis? What do y'all think? You have to think. Sine, is it going to start down here, or does it start? Did I say the y-axis?
Yeah, you did.
Oh, I'm sorry. Does it start on the x-axis? There. Okay. So point 1. Now, is it going to go up, or is it going to go down?
Down.
Down, because of that negative 1/4. Okay. 1, 2, 3, 4, 5. So those little pink dots. And you can probably get the graph drawn without the actually drawing the curve. Once you have the pink dots, it's going to be an asymptote at negative pi over 2, positive pi over 2, 3 pi over 2, and like that, like that. Problem number 3. So here's, ooh, let me see, how can I do this? Sort of hard to see those, isn't it? You know what? Let me do this. Okay, so here are our answer choices, and it's not A or D. We've already knocked those out. So let's look at, it's sort of hard to tell, it's either B or C, but if you look closely, generally I always target the y-axis if I can. Look at what's happening at the y-axis. It should be going, have the U-shaped curve there. This is the x-axis, y-axis. Which one looks like it's doing the correct thing at the y-axis? Is it B? Yeah, the answer here is going to be B. Yeah, this paper graphs that I printed out here, they don't look like, it looks so tiny, but once you actually start doing them on your own, then, I mean, if you're doing it online, it works out pretty nice. Any questions there? Let's do one more of these. Let's see. Let's do problem number 6. Let me see how this goes. I'm zooming in on this stuff, but the thing that's being recorded is the unzoomed. So, problem number 6. Okay. Oh wow. I don't think we can just look right off and knock out 2 of them, can we? So whoever wrote this program, the program for these graphs, they were sort of tricky here, okay? So you can't just knock out two of them right off. So this is problem number 6. Let me write it down. Number 6. Y equals -2 secant 4 pi x plus pi. Well, what am I going to graph first? Well, graph y equals -2 cosine 4 pi x plus pi. What's the amplitude for this cosine curve? What, 2? Okay. To figure out where it starts and stops, let's take the angle 4 pi x plus pi, set it between 0 and 2 pi. And how would I go about solving this for x? Let's see. Looks sort of messy, but I think it's going to work out really nice. We'll subtract pi all the way through. 0 minus pi is -pi. So we just have 4 pi x in the middle. 2 pi minus pi is pi. What is it? The common mistake, people will see 2 pi minus pi and write what? 2. Yeah. So, but there's 2 pi minus 1 pi. 2 apples minus 1 apple. Doesn't leave the number 2. It leaves 1 apple. Divide both sides, or divide straight through by 4 pi. And here the pi's cancelled, aren't they? So it's going to be, this graph will be bouncing between -1/2, -1/4. Where did I get a -1/2? Should be a 4 here. And what over here? A +1/4? I'll scribble there. It's a 4. So -1/4 and +1/4. And let's see, what color is this? Orange. Okay. Drawing my rectangular coordinate system. And on the x-axis, we're not going to have any pi's labeled. -1/4 to +1/4. Let's see. I think I want it bigger than just one box being a 4th. If I do that, it's going to be so small. So how about I do this? I think I'm going to use, how many little boxes do you want to use for 1/4? Would it bother you if I use 3? 3 little boxes? So there's, oops, I wrote pi over 4. -1/4. I'm using 3 little boxes and +1/4. And make this a little bigger. And we're graphing cosine and okay, and it's been multiplied by negative, so it's going to be bouncing between, did we decide on that? What two numbers does it bounce between on the y-axis? 2 and -2. So, does cosine start on the x-axis or not? I think I nearly did it again. Does cosine start on the x-axis or not? Okay, sine starts on the x-axis. Cosine Okay, it's either going to start up at 2 or negative 2. Which one?
Is it negative 2?
Yeah, negative 2. Okay, so it starts here. 1. Ooh, let's see. Now, 2, 3, 4, 5. Ooh, I was going to do that in pink and I forgot. So here's, you might, there. So there's the graph of negative 2 cosine 4 pi x plus pi. Draw your asymptotes. Oops. I messed up. The asymptote here, right out there. And here. Sort of messy, doesn't it? Then draw the little reciprocal curve. So like that. Like this. And like that. And I always, generally if you just target the y-axis when you're ready to look at the choices, that'll be enough generally. Let's see. I'll put this one here and move up. Look at what's happening at the y-axis. It should be opening up, has that little U curve. There's not an asymptote on the y-axis. So looking at these, best I can do. A, B, C, D. Which one looks like it's got the correct thing at the y-axis? Is it D? Okay, it's a D, isn't it? If you're wondering, well, where are these 1/8 coming in? What's half of 1/4? Can you tell me what half of 1/4 is? 1/2 times 1/4 is 1/8. That's where this asymptote right here is. It would be at 1/8. And then over here, half of 1/4 is, well, of negative 1/4 is negative 1/8. So there's an asymptote at 1/8, at negative 1/8. If it keeps going, the next one would be at negative 3 pi over 8 and so forth. Even though the graph is going from negative 1/4 to positive 1/4, the answer is not going to be the one that has negative 1/4 and positive 1/4 labeled. Notice you don't have asymptotes at negative 1/4 and positive 1/4. That's why the answer sure isn't A or B. A and B have the asymptotes occurring at negative 1/4 and positive 1/4. And that's not what it is. Normally, is it clear what I mean when I say I target the y-axis? Look at what's happening here on the y-axis. Okay? Right out there, it's got that all going up. Which one of these has that happening on the y-axis? Well, it is D. Okay? Any questions there? And this assignment was so short, because there's only 6 of these graphing things here, I decided, okay, let's fill up some space with everyone's favorite. So, starting with number 7, what's y'all's favorite thing we've done this semester? Oh yes, those identities. Wow, y'all are going to make everyone that watches this video think y'all are just so, let me unzoom this. So okay, I put in 4 problems where just simplify these identities just to get the assignment up to 10 problems. Okay, so do we have time for me to do some of them? Yeah. Well, I think I'll just go ahead and work through these problems here. Hopefully these, when you do them, they'll regenerate and they won't be exactly the same as what I'm doing here. Sometimes with these identities, it's sort of hard for it to regenerate off very much.